All right, now that we are done with experiment 3, let's talk about experiment 4. And in experiment 4, we're actually looking at natural selection. As always, I have to remind you right here, we have to reset everything back to the original settings. Basically, we have to reset it, right? So basically, we come back here. Again, these are the results of the old experiment, which I don't need anymore. So I'm going to hit the refresh button, and we will start anew. So now that this is ready to go, let's actually talk about the experiment before we run it. This time, because you are simulating natural selection, you will change one of the parameters, right? We always change at least one of the parameters. Under evolutionary parameters, you will see genotype relative fitness. And I'm going to show you this. I'm going to read it now, and then I'm going to show you next. Show you after this. Under genotype relative fitness, you will see all 3 genotypes, right? So there's homozygous dominant, which is the orange fish. There's homozygous recessive, which is the white fish. And there's heterozygous, which is the spotted fish. And when we look at it, as you'll see when I show you in the video, they are all set to 1, meaning there is no advantage, right? There is no advantage to being white. There is no advantage to being orange. There is no advantage to being spotted. But we're going to change that. You will leave the little r set to 1. In other words, the white fish, that means being white is advantageous, right? That genotype, little r is advantageous. That means the phenotype, white, is advantageous, right? And if you remember back from my earlier video, I used a hypothetical example, like let's say the fish pond, for some reason, somehow a bunch of white marble pebbles got put into that fish pond. So now the white fish can easily hide from the predators because they are white and so are the pebbles. So that is an advantage. That's one change we'll make. And again, I'll show you on the website here in a second. The other change you're going to make is changing the big R, little r genotype to 0.5, which means, right, it started at 1, so that means we're decreasing it to 0.5. That means it's not as advantageous as it used to be. It's actually going to be kind of neutral because, again, in this weird hypothetical situation, I said, it's a bunch of white marbles, white rock, so the white fish has an advantage. But if you're white with orange white with orange spots, you still have a little bit of advantage. Not as much as being completely white, but you still have some. And that's what that change means. And then the last change you're going to do is we're going to change big R to 0. And what that means is it's lethal, right? You're at a disadvantage if you're orange, because again, in this hypothetical example I'm giving you, let's just assume that the pond changed to a bunch of white pebbles. So now those orange fish just stick out like a sore thumb, and the predators eat them and they die. Therefore, they don't reproduce. Therefore, they don't pass along those genes. So that's what we're doing. Now let me show you how to do it. Let's go to the website. As always, we're going to hit run experiments. And then as always, we need to hit that pause button right away. Otherwise, the experiment starts without us putting in the parameters that we need. So here we go, run experiment and pause. All right, paused it right away. Again, all this is set where it needs to be. For some reason, this is never set where it needs to be because we want no migration. So make that 0, right? So we don't have anybody coming in, no fish coming in, no fish coming out. Mutation rate, that's set where it needs to be, no mutation. Either big R to little r or little r to big R, no changes there. Here's the part we're changing, relative fitness. So again, we're going to say the white fish are at an advantage, so we'll keep that as a 1. The orange fish, no, that is disadvantageous, right? Because like I said, they're orange fish in a pond with white stone. So imagine this was a bunch of white stone in this pond instead of purple or whatever color that is. And then, of course, like I said, being white with orange spots, that's halfway in between, right? So we're going to set it to 0.5. You're not sticking out like a sore thumb like the orange fish, so you're not 0. You're not completely blending in like the white fish, so you're not 1. So what's in between 1 and 0? 0.5. So there we go. We've set the parameters where we need them. before we can hit the play button and start the experiment, remember the purpose, in a sense, purpose of these experiments is to be able to fill in the tables, fill in the data. I don't like the way that's broken up, so I'm just going to put that down there. There we go. So again, we need to fill this table out. That's the purpose of these experiments, is to be able to fill in this data. So here we go. Again, we can't hit the play button yet because we need to fill in the data. So here's the data we need. All this information here is going to be used to fill in this right here. This is the initial data. This is the data before we start the experiment. This all comes from right here. As always, we hit the play button. As usual, I'm going to speed it up to 16. That's just the way I want to do it. And again, we're trying to hit 100 generations, so I'm just sitting there waiting for that. I can look at these things as they change. I can see already that we're getting a lot more homozygous dominant or recessive fish, right? A lot more white ones. The red ones are almost extinct. The orange ones are really low too, because remember, the way we ran the simulation, being white was an advantage, right? It was hidden from predators. Here we go. All right, I came close. I almost hit 100. That's good enough. And again, like I said, for your own experiments, you can do over 100 if you want. You can go as long as you want for your experiments. But when you do the table to keep it accurate, this is not after 100. In my case, it's after 101 generations. All right, so again, remember, we got this information before we ran the simulation. And now that we're done with the simulation, we're going to fill this in. And again, all that information comes from right here. So we're going to take this data right here, and we're going to fill this in. And once you've done that, at that point, you will have all this data filled in. And that's all of the data that you collected from your experiments. And once you've done that, as always, you can then calculate the differences in the percent change. And then once you have all that, you can actually look at the results and see how things changed. And again, not that you can use this for the chart or for the written portion of this exam, excuse me, of this lab, but we can look at it and I can see the changes, right? Forget the numbers, because you'll deal with the numbers in the table. I can see that even though we started equal towards the end here, that big R allele is almost completely gone, right? You can look at the graph, right? We have so many white fish, very few orange or spotted fish, and almost no red fish. So anyway, that's how that works. And that is the end of experiment 4. Matter of fact, that is the end of all experiments. So once at this point, that should mean that you're done filling in all the data from all 4 experiments, and you've calculated all the changes that are, you've done all your calculations that you need. So you're done with the tables. So the next section in the next video is going to discuss analysis. So from there, we're going to analyze all this data that we just collected and calculated.